Good afternoon, my name is Joseph Kingston and today I'll be running you through our learning application for Whose Fault Is It? Police officers investigated a crash at the intersection between Hoadley Court and Ballarat Road near Footscray Campus, Victoria University. The two cars involved were a Mitsubishi Outlander Aspire and an Audi A3 Sportback. The Mitsubishi driver claims that the Audi had suddenly driven into the intersection from Hoadley Court, and the Audi driver claims that he was already in the intersection at a green light waiting to make a right turn onto Ballarat Road, and he claims that the Mitsubishi driver was speeding and had jumped the green light. Both drivers were examined by the police and found to be sober. For this assignment, we're going to make a couple of assumptions. We're going to assume that during the collision, energy is lost only to friction and not to deformation of metal. We will also assume that the curb masses offered by the manufacturers are correct, and that once adding the masses of the drivers, the Mitsubishi will be weighed at 1,642 kilograms, and the Audi will be weighed at 1,305 kilograms. And we're also going to assume that the Audi is the 1.4 litre model. The information given to us by the Vic Police tells us two helpful things immediately. The direction and magnitude of the skid marks left by the colliding vehicles, and the dynamometer results of the tyre compounds. From this graph, we can find the coefficient of friction between the tyre and the road, found by dividing the amount of force needed to keep the tyre in motion or to set the tyre in motion by the normal force exerted by the tyre, and plugging our numbers from the graph into the calculator, we can see that we have 0.82 and 0.71 respectively as our coefficients of friction. Conservation of energy tells us that the change in energy from the point of collision to the point of stopping of the collision is equal to the work done by friction. Now we know that change in kinetic energy is equal to the final kinetic energy minus the initial kinetic energy. And we know that the final kinetic energy, because there is no motion, is 0. We can define kinetic energy as a half mv squared, and we can define the work done by friction by mu k, the normal force, times by the displacement. And rearranging our equation and plugging our numbers in for velocity, we end up with a velocity immediately after the collision combined of 6.98 meters per second. Having found the combined velocity of the cars immediately following the collision, now we need to break them down into their vector components of velocity to find the vehicle's speeds in their axis of motion. For the x-axis, or the Mitsubishi, we can break down the velocity into its horizontal component using cosine, and then with our definition for conservation of momentum, because we know momentum is conserved immediately before and after the collision, we can rearrange for velocity and plug our numbers in to get a initial velocity before the collision of 11.77 meters per second squared, and do the same thing for the Audi in the y direction to get initial velocity of 5.39 meters per second. Based on context clues from before the collision, we can see that the Mitsubishi brakes 10 meters before the collision, leaving sporadic skid marks after ABS system was deployed. Due to the locking and unlocking motion of the ABS, we can't assume that the car was being worked on by kinetic or static friction, but rather an unknown combination of the two. And so for our calculations, we'll find the velocity before braking for both situations individually. Breaking that down, we have our initial kinetic energy is equal to our final kinetic energy plus the work done by friction. Of course, our definition of friction is mu normal force times displacement, and our definition for kinetic energy is a half mv squared. Expanding and rearranging for v, and for kinetic we did the same thing but with the kinetic function of friction, and plugging our figures into it, we get 17.27 meters per second or 62 kilometers an hour using static, and 16.67 meters per second or 60 kilometers an hour using kinetic. With the evidence against all components of the Audi driver's story, mathematically we can prove that he was driving into the intersection, not stationary waiting, and we can also conclude that the Mitsubishi driver was not visibly speeding. We can say that most of the Audi driver's story was false. However, because of the timing between traffic lights, we can't rule out that the Mitsubishi driver did in fact run a red light and T-bone the Audi, but most probably the Audi was at fault. Thank you very much for listening.